let's understand post-tension terminology and its practicality. Post-tensioning is a construction technique that strengthens concrete by applying compressive stress to offset tensile stress. It involves installing and tensioning high-strength steel tendons in concrete after the concrete has been cast. Post-tension concrete is a mainstay technique of modern engineering and building projects. These post-tensioning methods are popular because they offer exponential improvements to the strength of concrete structures. Post-tension structures, while improving strength, can also reduce concrete and steel material costs. By placing concrete under compression, post-tension structures are less likely to crack. Thinner, concrete post-tensioned slabs allow builders to accommodate more floors in high-rise construction, maximizing return on investment. By profiling the strands, designers can control how the load is distributed throughout the structure. Stronger post-tension concrete structures typically require fewer supports, ideal for projects that require longer spans, including bridges. When building with post-tension concrete, projects consume fewer resources without compromising strength or quality. By using fewer materials, project costs fall, profit margins strengthen, and the carbon footprint of the project shrinks, all important goals of any construction program. Before we understand how post-tension works, let me take this opportunity to thank my subscribers for making us reach 500, but I am looking forward for more subscribers as we continue to support the growth of the channel in order to make us acquire construction basic knowledge. We also do value your comments as they help us improve on our channel. Thank you. How does post-tension concrete work? A brief overview. Post-tension concrete combines the relative merits of concrete and steel to deliver a final product that is much stronger than either used alone. Concrete offers superb strength when under compression. However, when that slab structure is placed under tension, it can be weakened and is prone to cracking. Rebar, adding steel reinforcement. Rebar, a passive reinforcement system, to the pour offers some tensile strength improvement, but it still has structural capacity limitations. Rebar reinforced concrete may still be liable to cracking for long, unsupported slabs, for instance. The solution? Post-tension concrete, which is an active reinforcement system. There are two main types of post-tension systems: bonded and unbonded. This video focuses primarily on the bonded post-tension method. A post-tension concrete structure will probably contain rebar, typically around the post-tension anchorage areas. Post-tensioning strands. The main element in the post-tension structure is the addition of the post-tensioning strands. These steel strands run through ducts embedded in the structure. The strands are secured at one end of the structure, with an anchorage device, and then passed out of the opposite edge of the structure. The installation process is generally relatively straightforward. Pouring the concrete or pouring then continues as normal, with special care taken not to allow concrete to leak inside the tending duct. Doing so risks creating rust and other long-term structural problems. Stressing the strands once the concrete has sufficiently cured. The exposed strands are stressed with specialist tools to create internal forces that place the concrete in compression to counteract external loads. The exposed end of the strand, typically referred to as the live end, is secured using an anchorage device embedded in the structure to maintain the desired tension for the lifespan of the structure. In many cases, after final tensioning, the duct may be filled with a cementitious filler to further protect the strands from corrosion and to bond the tendons to the ducting. Adding post-tensioning in this way allows for the creation of a far stronger concrete structure with superior wind and seismic resistance qualities. Where is post-tension concrete used? Stronger, longer, thinner and more crack-resistant than traditional structures. There are many places where post-tension concrete is used, including bridges. Long, load-bearing bridge spans are perfect for crossing gaps at height. Skyscrapers, by using post-tension slabs to reduce deflections and cracking, allowing for thinner slabs and larger spans between supporting columns. Parking structures. Again, large spans between columns are essential for maximizing available space for car parking. Industrial floors. Fewer floor joints and less cracking make post-tension concrete an extremely durable surface for factories and other industrial structures. Sports stadiums. heavy load-bearing capabilities, and cantilevered architecture require high-tensile concrete solutions. Indeed, any application where there must be long, unsupported stretches of load-bearing concrete is a candidate for post-tension slabs. What equipment do you need for post-tensioning concrete? The steel strands running through post-tension concrete are typically placed under 33,000 pounds force (lpf) tension. To support this high level of tension, tendons are made from very strong, 7-wire, spiral wound steel. Delivering a precise level of tension requires specialist tools, specifically stressing jacks and tensioning pumps. Hopefully my viewers, you have understood the term post-tension and its practicality.